Welcome back, everyone. Today we're taking a deep dive into biomedical AI, specifically how it's learning from images to make sense of, well, medicine.
It's a really exciting field.
Yeah, I was reading through the research you sent me,
Yeah.
and wow, this stuff is pretty mind-blowing. We're talking about AI that can understand X-rays, CT scans, even microscopic images.
Absolutely. And we're even seeing AI start to answer those complex medical questions that researchers have been grappling with for years.
It's amazing. And you know what really caught my eye? These four systems, MedInsights, Biomed CLAP, Reduno, and LaviMed. I mean, these are some seriously cutting-edge AI models.
They really are at the forefront of what's possible.
So before we get into the nitty-gritty of these specific systems, I think it's important to understand this whole concept of multimodal AI. I keep seeing that term pop up in the research, but can you break it down for us? What makes it so important in biomedicine?
Sure. You see, traditionally, AI models in biomedicine kind of worked in isolation. Some focused on images, like analyzing X-rays, others on text, like patient records.
Right, so they were kind of like specialists, each focused on their own area.
Exactly. But the thing is, in biomedicine, everything's connected, right?
Yeah.
You need both the images and the text to get the full picture.
I see. So, like, a doctor needs to see both your X-ray and read your medical history to understand what's going on.
Exactly. And that's where multimodal AI comes in. It can process both images and text at the same time, making those connections, building a richer understanding of the data.
That makes a lot of sense.
Yeah.
So it's like having an AI that can not only read a patient's medical history, but also look at their X-ray and understand the connection between the two.
Exactly. It's breaking down those silos and leading to some really groundbreaking insights.
It's like giving AI a whole new level of medical understanding.
Mm-hmm.
So to get this smart, to make these connections, these AI models need to learn from a lot of data, right? And I know you mentioned a really important data set called PMC15M.
Yeah, PMC15M is pretty amazing.
I mean, 15 million pairs of biomedical images and text, all pulled from scientific publications. That's a massive amount of data. What makes it so special? Why is everyone so excited about it?
Well, first of all, it's just huge, I mean, it's way bigger than any previous biomedical data set, and that means it's a massive training ground for these AI models.
It's like giving them a crash course in all things biomedicine.
Exactly. The bigger the data set, the more the models can learn, the better they get at understanding those complex relationships between images and text.
Okay, so size matters.
Yeah.
What else is special about PMC15M?
Well, it's not just the size, it's also the variety. PMC15M covers a huge range of medical images: X-rays, CT scans, microscopic slides, you name it.
So it's not just focused on one particular area of medicine.
Nope, it's like a universal medical data set.
Yeah.
And that means it can be used to train models that can handle different medical specialties, from radiology to pathology to cardiology.
It's like training a medical AI that's well-versed in all different areas of medicine, right?
Right, it's like giving them a broad medical education. And on top of that, PMC15M is publicly available, so researchers all over the world can access it. It's a real goldmine for anyone working in biomedical AI.
Open access to data is so important. It really democratizes research, allows for more collaboration and innovation. So we've got these super smart multimodal AI models fueled by this enormous, diverse data set like PMC15M. Now let's zoom in on one of these specific systems you mentioned, Biomed CLIP. What makes it such a powerhouse?
Biomed CLIP is, well, it's really interesting because it's one of the models trained on PMC15M, and it uses a really cool technique called contrastive learning to understand those relationships between images and their captions.
Contrastive learning. Okay, I'm going to need a little help with this one. How does that work?
Okay, imagine you show the model an X-ray, right? And alongside it, you have the radiologist's report. So with contrastive learning, Biomed CLAP is essentially learning to match the visual patterns in that X-ray with the descriptions in the report.
So it's like a giant matching game for medical images and descriptions.
Yeah, exactly. It's learning that a certain shape in the X-ray corresponds to a specific term in the report, like fracture or tumor or whatever it might be.
So it's building those connections between what it sees and what it reads.
Exactly. It's learning to see the meaning behind the image, not just the pixels.
Okay, that makes sense. But how does this contrastive learning actually translate into real-world applications? What can Biomed CLIP actually do?
Well, it's shown some amazing results in a couple of key areas. One is image classification. So you can show Biomed CLIP a medical image, and it can accurately categorize it into different conditions.
Like, it could tell you whether an X-ray shows signs of pneumonia or a broken bone.
Right, but here's the really cool part. It can even classify images it's never seen before.
You mean, like, if it's never encountered a specific type of fracture, it can still recognize it?
Exactly. We call this zero-shot image classification. It's like you show a picture of a rare skin rash it's never seen before, and based on its knowledge of visual features and medical terms, it can still make a pretty accurate diagnosis.
Wow, that's incredible. It's like it's learning to think like a doctor, analyzing the image and connecting it to its vast medical knowledge.
Yeah, it's pretty impressive. And it's not just about classification either. Biomed CLIP is also really good at visual question answering.
Okay, what does that mean? Like you can ask it questions about an image.
Exactly. So you could show it a brain scan, for example, and ask, is there any sign of a tumor? And Biomed CLIP can actually analyze the image and give you an answer based on what it's learned.
Wow, that's amazing. So it's not just recognizing patterns, it's actually understanding the meaning of the image
Yeah.
and using that to answer questions.
Right. It's taking medical image analysis to a whole new level.
That's really exciting stuff. So that's Biomed CLIP. We've got this image classification and question answering genius. But what about LavaMed? What's that one all about?
Well, LVMed is like having a biomedical research assistant, but one that can also see.
A research assistant that can see. Okay, now you've really piqued my curiosity. How does that work?
Think of it as a chatbot, but one with a medical degree.
A chatbot that can analyze images and answer questions about them.
Exactly. You can ask it open-ended questions about medical images, and it can respond in a really conversational way.
Wow, that sounds like something straight out of science fiction.
It might sound futuristic, but it's becoming a reality.
So how does it actually work? What's the technology behind this seeing chatbot?
Well, EleMed builds upon another model called ELEVA, which is a general-purpose vision language model, but ElevaMed has been specifically trained on tons of biomedical data, and it uses this really cool approach called curriculum learning.
Curriculum learning. Okay, you're going to have to explain that one.
It's pretty simple, really. It means that ElevaMed learns in stages, just like we do in school. It starts with basic medical concepts and then gradually moves on to more complex ones.
So it's not just bombarded with a mountain of medical information all at once.
Nope. It's a step-by-step learning process. It builds a solid foundation of knowledge before moving on to more advanced topics. And this approach has made LaviMed incredibly efficient. It was actually trained in under 15 hours.
15 hours. That's incredibly fast for such a complex model.
I know, right? It's remarkable, and it really highlights the power of leveraging existing models and data.
That's amazing. So we've got Biomed CLAP, the image classification and question answering genius, and AlviMed, the biomedical chatbot with X-ray vision. Now, what about RedDuno? What makes this one stand out?
Well, RedDuno is kind of like the rebel of the group.
The rebel. Okay, now I'm really intrigued. What do you mean by that?
Well, you see, most of these models, like Biomed CLAP, they learn from both images and text, right?
Yeah, that's the whole idea behind multimodal AI.
Right. But RedDuno takes a different approach. It challenges that assumption that you need text data to understand images.
Wait, so RedDuno is learning to understand medical images without any text at all?
Exactly. It's like learning a new language just by looking at pictures.
That sounds incredibly difficult. How is that even possible?
It uses a self-supervised learning approach called DynoV.
Dyno V2, what's that all about?
Well, it basically means that the model is learning to recognize the structures and patterns within the images themselves. It doesn't need text labels telling it what it's seeing. It's learning directly from the visual data.
That's mind-blowing. It's like RedDuno is teaching itself to be a medical image expert.
Yeah, it's pretty amazing what it can do.
But why go to all this trouble to avoid text data? Isn't having that extra information helpful?
Well, relying on text data can sometimes introduce bias. Imagine if the text data used to train the model contains outdated or inaccurate information. The model might then learn to repeat those biases, and that could lead to problems.
That makes sense. It's like learning history from a textbook that has some facts wrong. You end up with a skewed understanding of the past. So RedDuno is taking a more objective approach, learning from the images themselves without that potential for bias.
Exactly. And the results are pretty impressive.
Oh yeah. How so? Well, RedDuno is actually performing as well as, or even better than, models that rely on text data for certain tasks. It's proving that this image-only approach isn't just a cool idea, it can actually work.
So this rebel is shaking things up and getting fantastic results. That's what I love about AI, always pushing the boundaries. What else can RedDuno do? What other amazing feats has it accomplished?
One of the most fascinating things is that it can actually predict patient demographics, like age and sex, just by looking at medical images.
Wait, what? It can figure out things about a patient that aren't even written down just by analyzing the image?
Yep. Even if that information isn't included in the reports, it's like Red Duno is spotting these subtle clues that even human experts might miss.
That's incredible. It's like having a medical Sherlock Holmes on your team. What are the implications of that?
Oh, the possibilities are huge. It could help us identify hidden health disparities or tailor treatments more effectively.
So, like, if Red Duno notices that a certain type of scan tends to look different in men versus women, it could help doctors develop more accurate diagnostic criteria.
Exactly. And it could lead to more personalized treatments, too.
That's a game changer. It's not just about reading images, it's about uncovering those deeper insights that can lead to better healthcare for everyone. So we've talked about Biomed CLIP, LAVMed, this incredible Red Duno, but we've got one more system to cover, right? Med Insights. What can you tell us about this one?
Well, MedInsights is kind of like a powerful search engine, but one specifically designed for medical images and their associated data. It can handle a huge variety of image types, from X-rays to CT scans to ultrasounds.
So it's like Google, but for medical images.
Yeah, something like that. But it's more than just a search engine. It can also analyze those images and extract valuable information.
So if I'm a researcher looking for specific types of medical images or trying to understand a huge collection of scans, MedInsights is my go-to tool.
Exactly. Imagine you're studying a particular type of bone fracture. You could use MedInsights to search a database of thousands of X-rays and quickly find all the images that show that specific fracture.
That would save researchers so much time and effort.
Right. It's like having a super efficient research assistant that can sift through mountains of data. But it's not just about searching either. MedInsights can also classify images with really high accuracy.
So let's say I have a bunch of chest x-rays. MedInsights can analyze those images and tell me which ones show signs of pneumonia, which ones show lung nodules, things like that.
Exactly. It's like having an AI-powered radiologist working alongside you.
That's pretty amazing. So it can search, it can classify. What else can it do?
It's also a powerful tool for identifying patterns and trends in large data sets of images. Like, it could analyze a collection of mammograms and pick up on those subtle features that might indicate early-stage breast cancer.
Wow. So it's not just about finding and classifying images. It's about uncovering those hidden patterns that could be crucial for early detection and prevention.
Right. And that's just scratching the surface. Researchers are constantly coming up with new ways to use MedInsights. It's really helping us unlock the power of medical images.
It sounds like we're entering a whole new era of medical discovery, powered by AI that can see and interpret the world in ways we never thought possible. These models, MedInsights, Biomed CLIP, Duno, LAVMed, they're already making a huge impact on research and diagnosis. But what about treatment? Can these systems also help us develop more effective ways to treat diseases?
Oh, absolutely. That's one of the most exciting frontiers in this field. One really promising area is using AI to personalize treatment plans.
Personalized treatment plans, what does that mean?
Well, right now, treatment for many conditions is kind of a one-size-fits-all approach, but everyone is different, right? We have different lifestyles, different genetics, different medical histories, and AI can help us take all of that into account when developing treatment plans.
So instead of just giving everyone the same medication or the same therapy, AI could help doctors create treatments that are specifically tailored to each individual.
Exactly. Think about it. Red Duno, with its ability to analyze images and extract all that subtle information, it could help doctors predict how a patient might respond to different therapies.
So it's like having an AI-powered medical advisor helping doctors choose the best treatment path for each patient.
You got it. It's personalized medicine taken to a whole new level. And the possibilities go way beyond that. AI is also being used to monitor treatment progress, to develop new drugs and therapies, to identify new uses for existing drugs.
Wow, this is incredible. It's like AI is becoming an indispensable tool for healthcare professionals.
Absolutely. It's helping them deliver better care in so many ways. And as these models become even more sophisticated and we gather more data, the potential applications of AI in medicine will just keep expanding.
It's mind-boggling to think about all the possibilities. But with all this talk about AI and its potential, I have to ask, are there any potential downsides? Any ethical considerations we need to be aware of?
That's a really important question. And yeah, there are definitely some things we need to think about carefully as we integrate AI into healthcare. Things like data privacy, algorithmic bias, the potential for job displacement. These are all important issues that we need to address.
Right, because AI is a powerful tool, but it's important to use it responsibly and ethically.
Absolutely. We need to make sure that AI is used to benefit everyone, not just a select few, and that it's used in a way that respects our values and our privacy.
Those are important points to keep in mind. So as we continue to explore the potential of AI in medicine, we also need to have these conversations about ethics and responsible use.
Exactly. It's about finding that balance between innovation and responsibility.
Well said. This has been a really fascinating deep dive into the world of biomedical AI.
I agree. It's an exciting field with so much potential.
And I'm sure our listeners are eager to learn more about how these advancements could impact their own health and well-being.
I think they have every reason to be excited. We're on the cusp of a real revolution in healthcare, and AI is playing a leading role.
That's a great note to end on. Thanks for joining us on this deep dive. We'll be back soon with more fascinating insights into the world of AI.
Looking forward to it. So you asked about what other amazing feats Red Duno has pulled off.
Yeah, its ability to predict patient demographics just from images is, well, it's pretty incredible.
Right. It's like it can see things that aren't even written down.
Exactly. So what are the implications of that? I mean, where could this lead?
Oh, the possibilities they're pretty huge, you know? I mean, for one thing, it could help us identify um, hidden health disparities.
Health disparities. Can you explain what you mean by that?
Sure. So, different groups of people, they often have different health outcomes, right? And sometimes those differences are due to, well, disparities in access to care or even biases in the healthcare system.
Right, like certain groups might not receive the same quality of care or might be misdiagnosed more often.
Exactly. And Red Duno, with its ability to analyze images in this really objective way, it could help us uncover some of those disparities. It could help us see if certain groups are being underdiagnosed or if they're not responding as well to certain treatment.
That's really important work.
Mhm.
I mean, if we can identify those disparities, then we can start to address them and make healthcare more equitable for everyone.
Exactly. And that's just one example, I mean, Red Duno could also be used to tailor treatments more effectively, like we were talking about earlier.
Right, personalized medicine.
Right. So, for example, if Red Duno notices that a certain type of scan tends to look different in men versus women.
It could help doctors develop more accurate diagnostic criteria for each sex.
Exactly. And that could lead to, well, more effective treatments, better outcomes for everyone.
That's amazing. So Red Duno is not just about reading images, it's about uncovering these deeper insights, these patterns that could really revolutionize how we approach healthcare.
Absolutely. It's about using AI to see beyond the surface, to understand the complexities of human health in a whole new way.
Well, you've definitely convinced me that Red Duno is a game changer. So we've talked about Biomed CLAP, LAV Med, and this incredible Red Duno. Now, what about Med Insights? How does this system fit into the picture?
So MedInsights, it's kind of like a powerful search engine and analysis tool, but it's designed specifically for medical images and all the data that goes along with them.
Data like patient records, lab results, that kind of thing.
Exactly. And it's built to handle a huge variety of image types from, X-rays to CT scans to ultrasounds, the whole gamut.
So if I'm a researcher, let's say, and I'm looking for specific types of medical images, or maybe I'm trying to analyze a huge collection of scans, MedInsights is my go-to tool.
You got it. Imagine you're studying, I don't know, like a particular type of bone fracture, right? Well, you could use MedInsights to search through thousands of X-rays and quickly find all the images that show that specific fracture.
That would be incredibly helpful. I mean, it would save researchers so much time and effort.
Right. It's like having a super efficient research assistant that can sift through mountains of data in no time.
That's amazing.
Yeah.
But MedSites can do more than just search, right?
Oh, absolutely. It can also classify images with really high accuracy.
Okay, what do you mean by classify?
So let's say you have a massive data set of chest X-rays, right? MedInsights can analyze those images and sort them based on whether they show signs of, I don't know, pneumonia or lung nodules or other conditions.
So it's like having an AI-powered radiologist helping doctors make faster and more accurate diagnoses.
Exactly. And it's constantly learning and improving, so its accuracy just keeps getting better and better.
That's incredible. So we've got searching, we've got classifying. What else can MedInsights do?
Well, one of the really powerful things about it is its ability to identify patterns and trends in large data sets of images.
Patterns and trends, what kind of patterns are we talking about?
Well, all sorts of things. Like it could analyze a collection of, I don't know, mammograms, for example, and pinpoint those subtle features that might indicate, early stage breast cancer.
Wow, so it's not just about finding and classifying images, it's about uncovering those hidden patterns that could be crucial for early detection and prevention.
Exactly. It's about using AI to see what human eyes might miss, to find those connections that could lead to, breakthroughs in diagnosis and treatment.
That's really amazing. So with Med Insights, it's like we're not just looking at images, we're looking at the bigger picture, right?
Mm.
We're seeing those connections, those patterns that could really change how we approach healthcare.
Absolutely. It's about using AI to understand the complexities of human health in a whole new way.
This is really opening my eyes to the incredible potential of AI in medicine. We've seen how it can help with diagnosis, research, and even treatment. It's like these AI systems are becoming essential partners for healthcare professionals, helping them deliver better care in countless ways.
Absolutely. And remember, these are just a few examples of what's possible. As these models become more advanced and we gather even more data, the potential applications of AI in biomedicine will only continue to expand.
This is truly groundbreaking stuff. But I have to ask, are there any potential downsides or ethical considerations we need to be aware of with all this AI in medicine?
Well, those are important questions to consider. Any new technology, especially one as powerful as AI, it comes with, potential risks and benefits. And we need to be really thoughtful about how we use it, especially in a field as sensitive as healthcare.
Absolutely. So let's dive into that a bit. What are some of those potential downsides or ethical considerations that we should be thinking about?
Well, one big one is data privacy, right? I mean, these AI models, they rely on huge amounts of data to learn, and a lot of that data is, well, personal medical information.
Right, things like medical records, test results, imaging scans.
Exactly. And we need to make sure that this data is being handled responsibly, that it's being kept secure, and that it's not being used for, any purposes other than what patients have consented to.
That's really important. I mean, people need to feel confident that their medical data is being protected, especially when it's being used to train these AI models.
Absolutely. And then there's the issue of algorithmic bias. I mean, these AI models, they're only as good as the data they're trained on. And if that data is biased, well, the model can be biased too.
So, like, if the data used to train an AI model comes from a population that's mostly white and male, for example, the model might not be as accurate when it's used to diagnose or treat people from other backgrounds.
Exactly. It could lead to, misdiagnoses, inappropriate treatments, even health disparities.
That's a serious concern.
Uh,
So how do we make sure that these AI models are fair and equitable? How do we address that issue of algorithmic bias?
well, it starts with the data, right? We need to make sure that the data sets used to train these models are diverse and representative of the populations they're going to be used on.
So making sure that the data includes people from different racial and ethnic backgrounds, different genders, different socioeconomic statuses.
Exactly.
Yeah.
And then we need to be really careful about how we design and test these models. We need to make sure that they're not perpetuating existing biases and that they're performing equally well across different groups of people.
So it's not just about the data, it's also about the algorithms themselves and how they're developed and evaluated.
Right. It's a multifaceted challenge, and it's something that researchers and developers are working on all the time.
It sounds like there's a lot of work to be done to ensure that these AI models are used responsibly and ethically in healthcare.
There is, but it's important work. And I'm actually really optimistic about the future. I mean, we're already seeing a lot of progress in addressing these ethical challenges. And I think as AI becomes more integrated into healthcare, we'll see even more focus on these issues.
That's good to hear, because ultimately we want to use AI to improve healthcare for everyone, not just a select few.
Exactly. It's about using AI to make healthcare more accessible, more equitable, and more effective for everyone.
Well said. So we've talked about the potential of AI in medicine. We've talked about some of the ethical considerations. But I think it's important to also remember the human element in all of this,
Right.
right? I mean, AI is a powerful tool, but it's not a replacement for human doctors and nurses.
Absolutely. AI should be seen as a tool to augment human capabilities, not to replace them. The best healthcare systems will be those that seamlessly blend AI with human expertise and compassion.
So it's about collaboration, not competition.
Exactly.
Huh.
Think of it like this. AI can help doctors with things like diagnosis, treatment planning, even monitoring patients, but ultimately it's the human doctor who's responsible for making those final decisions, for providing that personal touch, for ensuring that patients feel heard and understood.
That makes a lot of sense. It's about using AI to empower healthcare professionals, to give them the tools they need to provide the best possible care.
Right. It's about using technology to enhance the human connection in healthcare, not to replace it.
Well said. This has been a truly fascinating deep dive into the world of biomedical AI, and I have to say I'm both excited and a bit awed by the possibilities.
I know, right? It's an incredible time to be working in this field.
And I'm sure our listeners are feeling the same way. We've seen how these models, like MedInsights, BioMedCLP, RedDuno, and LavaMed, can analyze images, uncover patterns, and even make predictions. But what does it all mean for us, the everyday people? How could these advancements in AI impact our health and well-being?
Well, on a broader level, I think these advancements really point to a future where healthcare is much more precise, more personalized, and ultimately more effective.
So we're moving away from this reactive approach to healthcare where we wait until we get sick to seek treatment and towards a more proactive preventative model.
Exactly. Imagine a future where AI is like your personal health detective, constantly analyzing your medical history, your lifestyle, your genetics, and flagging potential risks long before any symptoms even appear.
Wow, that's like having an AI-powered early warning system for your health. It's a bit like those sci-fi movies where they can predict health issues years in advance, but that sounds pretty far off. Are there ways that AI is already making a difference in people's lives right now?
Oh, absolutely. Think back to those amazing diagnostic capabilities we discussed earlier. AI models are already being used to help radiologists detect cancers earlier when treatment is most likely to be successful.
So that tiny shadow on your lung x-ray, or that suspicious spot on a mammogram, AI could help make sure it doesn't go unnoticed.
Exactly. And these models are constantly learning and improving. As they get more sophisticated, they'll be able to assist in diagnosing a wider range of conditions, leading to faster, more accurate diagnoses for everyone.
That's a real game changer. Earlier and more accurate diagnoses could make a huge difference in treatment outcomes for so many people. And what about treatment itself? How could AI personalize healthcare on a truly individual level?
Let's think about those chronic conditions that affect so many people, like diabetes or heart disease. AI could help doctors develop treatment plans that are truly tailor-made for you, taking into account your specific needs and lifestyle.
So instead of a standard prescription or a one-size-fits-all approach, AI could help doctors fine-tune your treatment to fit your individual needs and preferences.
Exactly. It's about considering factors like your diet, your exercise habits, your sleep patterns, even your genetic makeup. AI could analyze all of that information and help doctors create a treatment plan that optimizes your health outcomes.
It's incredible to think that AI could help us move towards truly personalized medicine, where treatments are as unique as the individuals receiving them. And we can't forget about the potential for new therapies and cures. AI is playing a huge role in accelerating drug discovery and development, right?
Absolutely. AI is being used to identify promising drug candidates, to design more effective clinical trials, even to repurpose existing drugs for new uses. It's leading to breakthroughs in areas like cancer, Alzheimer's disease, and those rare genetic disorders that have been so challenging to treat.
It's mind-blowing to think that the cures for some of humanity's most challenging diseases could be discovered with the help of AI. It's like we're standing on the brink of a whole new era of medicine, and it's all thanks to these incredible advancements in AI.
I agree. We're witnessing a real paradigm shift in healthcare, and it's incredibly exciting.
Well, we've covered a lot of ground in this deep dive into biomedical AI. We've explored the incredible potential of these AI models to revolutionize healthcare, from diagnosis to treatment to drug discovery. But we've also talked about the importance of responsible and ethical use, ensuring that these technologies are used to benefit everyone. As we wrap up, I want to leave our listeners with something to think about. We've seen how AI can analyze images, spot patterns, and even make predictions about our health. But what if AI could go beyond just predicting the future? What if it could help us create a healthier future for ourselves and for generations to come? That's something worth pondering, isn't it?
It certainly is. It's a challenge and an opportunity, all rolled into one. And it's something that we all need to be thinking about as we move forward into this exciting new era of AI-powered healthcare.
Well said. Thanks for joining us on this deep dive. We'll be back soon with more fascinating explorations of the world of AI. Until then, stay curious and stay healthy.
See you next time.